Did you ever think, why galaxies come in different shapes? How are these shapes created for every galaxy? Hi, this is Rumela from Awakening Sci-Fi Stories, presenting you the unknown story of galaxy formation. NASA and the Hubble Heritage Team have estimated that there are around 200 billion galaxies in the observable universe. But when we see other types of galaxies portrayed in science fiction films, they tend to have the same basic shape as ours. This would be an example of our human-centered biases. Although many of them do resemble the Milky Way, others come in wildly different shapes and forms. You've probably seen illustrations of our home galaxy hanging on the walls in countless science classrooms. But we bet you didn't know that those posters are proportionately thicker than a key component of the galaxy itself. That's right. Like a fried egg, the Milky Way consists of a central bulge surrounded by a flat, thin disk. And when we say thin, we mean mind-bogglingly thin. As physicist and Forbes correspondent Gillian Scudder points out, the disk of the Milky Way galaxy is around 100,000 light-years long, but only about 0.6 light-years tall. This means that, proportionally, it's 30 times thinner than a typical sheet of printer paper. But we're getting ahead of ourselves. Before we learn more about what makes the Milky Way unique, let's take a step back and talk about what all galaxies have in common. What is a galaxy? Galaxies are complex systems held together by gravity. They're made up of gases, stellar dust, and millions, sometimes even billions, of stars, which are accompanied by their own planets and asteroid belts. Out of the more than 200 billion galaxies, many have a spiral shape like the Milky Way. There are a few other galaxy types, including irregular galaxies, elliptical galaxies, and lenticular galaxies. Dwarf galaxies, which are smaller and have fewer stars than spiral and elliptical galaxies, come in a variety of shapes and sizes. How do galaxies get their shapes? Every galaxy has a unique story to tell. The history of each one is evident in its shape. Scientists divide galaxies up into a handful of appearance-based categories. The Milky Way is what's known as a spiral galaxy, meaning that it looks like a broad, flattened disk with a slight bulge protruding outward at its center. That arrangement is the product of rotation speed, time, and gravity. It's a field that invites a lot of debate. The physics of how these things form is not completely known or settled. Nonetheless, it's widely thought that most spiral galaxies begin their lives as spinning clouds of gas and dust. The speed at which they rotate matters a great deal. The massive, rapidly rotating clouds are more likely to become spiral galaxies. Gravity attempts to pull these spinning amorphous bodies into flattened planes. Over time, the clouds contract because of gravity and loss of energy due to friction. And due to a principle called the conservation of angular momentum, when a spinning object contracts, it rotates more rapidly. You can see this in action at your local skating rink. Experienced ice skaters know to increase their twirl speed by drawing their arms inward. Spiral galaxies, like Galaxy NGC 4302N and Galaxy NGC 4298, are examples of this. They appear different in the image taken by the Hubble Space Telescope on April 24, 1990, because they are angled at different positions in the sky. So, much like a spinning blob of pizza dough, spiral galaxies form when shapeless gas and dust clouds flatten out at high speed. The same physical forces also affect the look of the pointed arms that can be seen around the rims of such galaxies. The types of spiral arms are almost certainly related to the rotation rate. Rapidly rotating systems tend to have a ring of small, tight arms. In contrast, those that move more slowly have longer, loosely wrapped ones. To understand why, let's try a little home experiment. Imagine stirring your coffee. Put a dollop of cream somewhere other than the center. You'll notice that the cream will form a spiral pattern. Then, stir the brew with a spoon. If you do so rapidly, the pattern's arms will get smaller and tighter. So, time for a quick recap. Thus far, we've talked about how spiral galaxies develop and how rotation shapes their arms. But what's the deal with those bulges we mentioned earlier? At the center of spiral galaxies, you'll find a cluster of very old stars revolving around a central point. This is the bulge. While the stars out in the disk move around in an orderly horizontal plane, the stars that comprise the bulge act like bees erratically swarming around a hive. Astronomers are still trying to figure out how these bulges form. Some speculate that they develop before the rest of a spiral galaxy does, while others think the reverse is true. Now imagine a galaxy that's all bulge. This thing would be disk-free and either look like a giant rounded sphere or a massive American football. Inside, its stars would orbit the galaxy's central point in all directions. Congratulations, you've just pictured an elliptical galaxy. It's important to note that some galaxies are neither spirals nor ellipticals. So-called irregular galaxies lack bulges and can come in a wide variety of shapes. Let's explore what is colliding galaxies. A near-galactic collision between NGC 2207 and IC 2163 spiral galaxies was captured by the Hubble Space Telescope in 2007. Scientists predict the Milky Way will collide with our neighbor galaxy Andromeda in about 3 billion years from now. NASA and the Hubble Heritage Team have observed some galactic mergers that are currently in progress. Maybe they'll look like nice, well-rounded ellipticals someday, but at the moment, these developing unions appear disorganized and distorted. There are also a few documented examples of big spiral galaxies cannibalizing smaller ones that have gotten too close, with the victim getting slowly devoured bit by bit. Experts project that our very own Milky Way will eventually collide with the nearby Andromeda galaxy, a process that'll reconstitute these two spiral galaxies into one elliptical galaxy. The process should begin about 3 billion years from now and finish in an additional 4 billion years from then. Obviously, it's not something any of us will live to see. But regardless, scientists have already come up with a name for this future elliptical galaxy. They call it Milkomeda. Next comes spiral galaxies. A spiral galaxy, like our own galaxy, has a central bulge and arms that spiral outward. Stars, gas, and dust make up these arms and create a distinctive appearance resembling a pinwheel. Since spiral galaxies come in different sizes and forms, some have more tightly wound spiral arms, and others have more loosely extended ones. Most galaxies are spiral galaxies, and within this category, barred spiral galaxies are the most recurrent subtype. A barred spiral galaxy features a central bar-shaped structure composed of stars, gas, and dust, and extending out from the galactic nucleus. Scientists hypothesize that the bar signals that a galaxy is fully mature. Another one is elliptical galaxies. An elliptical galaxy, which has a smooth ellipsoidal or spherical shape, does not have well-defined features, such as arms or disks. Composed of older stars, they typically contain relatively little interstellar gas and dust. Researchers believe an elliptical galaxy could be a result of colliding galaxies. Giant elliptical galaxies, a subtype of elliptical galaxy, are among the largest and brightest galaxies and are often at the center of a galaxy cluster, a collection of galaxies held together by their mutual gravitational attraction. We also have lenticular galaxies. A mix of spiral and elliptical galaxies, lenticular galaxies have a central bulge, older stars, and a flat disc-like structure. They do not have well-defined spiral arms. Some theories posit that these galaxies do not have arms because they have since faded. Another theory says that lenticular galaxies formed from the merging of spiral galaxies. There is a galaxy called Irregular galaxy. As the name suggests, an irregular galaxy does not have a well-defined symmetrical shape or structure. The shape could have resulted because of galaxies colliding or the gravitational pull of another galaxy. They do not have a specific pattern of stars, gas, and dust. They can have a mix of old and young stars. It is interesting to know that the word galaxy derives from the Greek word gala, which means milk, as in Milky Way. Ours has a luminous band of stars that's clearly visible in the night sky. To ancient astronomers, this looked like a swathe of spilled milk. So hope you enjoyed the video. Stay tuned to more stories about these cosmic creations. Thank you.